Okay, nice to meet you guys. My name is Song Lim and I will explain about the loss experiments. This is our index for the today's lectures, and this is our robot named as the high wonder jet robots. It captures the Zasnuri Nano 8 GB, and there are loss number is already installed, so you can just plug and play. This is this package. So this one is probably about the default setup for the loop systems. Whenever you are just opening your building something, then you can just with these kinds of things for the refreshing the OS to recognize your building systems. So you're just building this one, and this one is make it as automatically, and you're just building the special shells. So you can just do, and then after this one, you can check your restorations by running the Totesim package. So this one can be the reset image for them. So now we will explain. We will move on to the how can we create a package for the ROS2. So we just usually making the Python package like this command line interface. So we are recommended to making package at the src folder. So this one makes your file systems make clear. So you just typing this command line and then just came back to the workspace and just running the build SSH for the build systems. So we are highly recommending build at the workspace because it is much simpler and making the file system clear. So and then after the building is done, then you will just search these kinds of things, or you just search the virtual for the refresh your root systems. So then after the package creation is complete, then we are now how can we make some loss node in this system. So you just create node like this one and making you can make move on to this file systems and then create this file and typing using some kind of Vim or Nano or something for the creating your node. So after that we are uploading our hello world file to our KLMS, so you can just copy out of that and just typing the files to make your node. After that, just make it as a change the mode to executable for the node, and then just using some kind of widths for using widths for that kind of things. And then after the build is done, then you can just start the node like this command. So the result is like this. So there are some hello world printing or update through the terminals. So now we will experiment about how can we make a publisher and subscribers. So actually there are some publisher examples in the command line interface. So we can usually making the node, run the node like this one, the Docker, and then you just typing this line for one terminal, and in another terminal you just typing this one for listening the topics from the Docker. Then you can see the message from the publisher is printed at the subscriber node, subscriber terminal. So yeah. Now explain about the slang. So actually, in today's lecture we will explain about the KAIST slang. So we briefly introduce the KAIST slang and explain the difference between the KAIST slang and the GMAP, which one is you guys are studied at the previous lectures. So KAIST slang is graph optimization based slang algorithms. The result map is like this one. It's actually 2D map, so you can easily mapping the system with a 2D LiDAR. And the mapping workflow is like this. The first one is the scan matching. The scan matching is for aligning the current LiDAR scan is the existing map and poses. And then next one is graph constructions. The graph construction is for the adding a node adding a new post node, and the constraint is for the graph, and then loop optimization is for the adjusting the entire graph when the loop closure is detected, so it can make the post automatically more precise. So the key features for the KAIST slam is like that. Actually, there are no particles, so it can be a very memory efficient, and also the loop closure making the consistent map in a long run. And the difference between the KAIST slam and mapping is like that. Because the KAIST slam is based on the optimization, so it does not use the particles. So it is very efficient for the computing, and it's very equitable with the computation resource limited environments like adjustments. And for the mapping, it is actually based on the particle features. So when the number of the particles increase, the computation and error is increased. So okay, now we will practice the KAIST slam is our adjustment robot. You can easily using the pre-installed KAIST slam systems like this command lines. You're just typing this one for the clean up the memories. This one for the operating slam. This one for the visualize your map in your IoT systems. And the last one is for the teleoperating your robot to mapping the internet systems. After the mapping is done, you can just saving the map like this line, command lines. This one should be updated for your custom map name, and then the map is saved to your file systems. Thank you.